Hey, what's up, guys? Welcome to my number theory YouTube video. And so today I want to talk about another new topic called primitive roots. And this is a very small topic that I heard when I was junior high school. But to be honest, I never understand until now. Okay, so that's why I want to make a series of maybe like 8 or 10 videos that quickly highlight each the results in these primitive roots. And I hope you guys subscribe to my channel. So this video just introduce the notation and I give you the final theorem that I want to include in this video. So reference that I think one reference is very good that is the Apostle, right? Or Apostle, the introduction to analytic number theory. And you can check chapter 10. Okay, and if you want to see more like any number theory, you can check out my video list. I think there are like 10 of them or like 50 of them. There are a lot of the topic. Okay, so let's say starting point, right? So assume that everybody know what number theory is and what basic idea. So basically, right, so let's say you consider a number m, where it's a positive integer, and m greater than 1, and then you consider the you take a, right? A is a non-integer, and then you can consider a squared, a cube, mod n, right? And so by the Euler theorem, so Euler theorem, you know that a to the phi of by the way, you need to assume that a and m are coprime, and then you consider this. So by Euler theorem, you know that is mod n. Okay, so you know that every number, so every a, right, will every a has the maximum order, right? So if you go to up to phi of m, you up to like phi of m, then you always become like 1 mod m. Okay, but I can define the order, right? Define the order. Let's we define the order called let's say this is order called the exponent of a modulo m. Let's call it f. The definition is just a minimum number such that the AF is 1 mod m. Okay, so we know that phi of m is the maximum, right? But for each a, there will be maybe a small one. Okay, so maybe it's a little bit hard to explain. Let's say consider a very simple example. Let's consider m equals to 4, and so a can be like 1 or 3. Okay, so we know that so when a is equal to 1, the order is 1, right? When a equals to 3, then 3 squared is 9, right? So it's 1 mod 4. So the order of the exponent of 3 modulo 4 is 1. That is 2. Okay, so order is 2. Okay, so usual notation. The usual notation is that I will write call the exponent of a modulo m. So it's using ma. Okay, so probably this is a bad notation, but basically you know that it's basically a to the f modulo m. Okay. Okay, so the definition, if f, right, is, or basically if the exponent of a modulo m is phi of m, basically this means that it need to go to the highest power to make it to be 1. Then a is called primitive roots. Okay, from this example, then we immediately see that 3 is a primitive roots. 3 is a primitive roots of 4. Okay, so very trivial theorem is that okay, so if a to the k equals a to the h mod m, if only if K is H mod F. Okay, so that's F is this. Okay, and A to K mod M if only if K is 0 mod F. Okay, so this means that you know that A to the basically just this tell you that F divides, right? So K must be multiplied of F, and so in general, this proves that your F must be the divisor of the phi of M. Number 3, and the 1a squared up to a to F minus 1 are incongruent. Congruent mod M. Okay, so this means that a to the x never equals to a to the y mod M when x, y are in this region. Okay, and these are somehow trivial, but let's maybe do some proof. Okay. Okay, so obviously that I can, if you go from 1 to 2 is trivial, right? Because you can just set h to be 0, then you have this, then you have this. Okay, so 1 per 2 is trivial. And obviously that this is true, right? Because 3 is true, right? If ax equals a of y, then if ax equals a of y, then you have a x minus y equals to 1 mod m. Then x, y smile will less than f. This violates the minimality of f. So 3 is also trivial. So the only thing we need to prove is number 1. Okay. The only thing we need to prove is number 1. And okay, so let's prove A or number 1. Sorry, number 1. Okay, so number 1 is let's say if A of K and A of H mod M, then we know that A of K minus H is 1 mod M. Okay, so let's write K of H. One can use division algorithm. So division algorithm writes QF plus R. Right, divide F. So where R is less than F. Okay, so this means that the 1 is A K minus H mod M, and there is A of QF plus R, and there is A of R mod M. Right, because A to F is 1. Okay, so this means that R is less than if R is non-zero, right? If R is non-zero, then this violates the minimality of F, so R must be 0. Okay, so prove the results. Since R must be 0, so K of H must F must divide K of H, or K of H must be 0 mod F. Okay, so why is this primitive root interesting? So the question is that given M is primitive roots exist or not? Okay, it's not necessarily exist, right? For example, let's check out very simple example. If you check M equals to 8, right, and so your A can be 1, 3, 5, 9, 7. Okay, and your A squared will be 1, 9, 25, 49. Okay, and then your A squared mod A will be 1, 1, 1, 1, right? Because this 9 mod 1, 9 mod A is 1, 25 mod is 1, 49 mod is 1. Okay, so no primitive roots, right? Because notice that phi of 8, right? 8 times half, so it's 4. So no primitive roots. Okay, so the question is that what kind of M will give you the primitive roots? Okay, very weird. Okay, so theorem, which very difficult to prove, very long and tedious. But I will make the several videos to make it happen. The following M has primitive roots. So have primitive roots. Basically, M equals to 1 to 4, and P of alpha and the P of 2 alpha. So P is R prime. So only the R prime only R prime the 2 times the P of R prime has the primitive roots. Other than that, no primitive roots. Okay, so as I proved, 4 has primitive roots, 1 is primitive roots, 2 is primitive roots. You can check it. Right? For example, 2 is just 1, right? 1 square. I mean, 5 2 is 1. And then 5 4 is 3. Sorry, it's 2. So 3 square is 1 mod 4. So 3 is a primitive roots. And okay, so this is the main theorem of primitive roots. Yeah, so in the textbook, it spent like 1 chapter to prove the following like fact. Okay, so see you guys next video. The next video that we will start to at least to prove. So this proof is tedious, right? Because I need to prove that oh this guy exists, but the rest don't exist. Right? So we need to separate into like a lot of parts. Okay, see you guys next videos.